Good morning, everybody. Welcome to the Blair Witch Project. I'm sorry. Good afternoon, everybody. Welcome to the JavaScript programming language. I'm Doug Crockford of Yahoo, and today we're going to talk about JavaScript. These are the things we're going to cover today. We're going to cover the history of the language. We're going to talk a lot about the language itself and some of its advanced features. We'll carry that on in the advanced JavaScript class that will follow. We'll talk about some of the platforms where JavaScript is available. We'll talk about the state of the standards, and we'll talk about programming style in JavaScript. JavaScript is, without a doubt, the world's most misunderstood programming language, and this owes to a number of factors. First off, the name. It has Java as its prefix, so a lot of people think that JavaScript has something to do with Java. Maybe it's interpreted Java or a subset of Java or something like that. It turns out it's none of those. JavaScript is almost completely independent of Java. It's a different language. And the suffix script suggests that it's not a real programming language. It's something, again, diminutive or not complete. But in fact, we're going to see JavaScript is a complete programming language. In fact, it's a pretty good one. It was intentionally mispositioned at its creation by Netscape and Sun Microsystems, and we'll talk about that history. The language contains some design errors, some of which have been corrected during the course of its evolution, some have not. And so it's a very popular language. It's probably right now the world's most popular programming language if you consider all of the platforms in which it's deployed. But the language has problems, and we'll look specifically at those problems. Early on, there were very bad implementations. And the language received a very bad reputation as a result of those bad implementations. The implementations have gotten good, quite good in fact, but the reputation of the language remains damaged. The language has been typecast. It's known primarily as the language of the browser. And so the browser, as we'll find out in the class, the theory of the DOM, is a really hostile programming environment. A lot of people think that the thing that makes the browser so difficult to do is JavaScript. But it turns out JavaScript is not the problem there. We'll look at that as we go along. The books about JavaScript are almost all universally bad. So it's very difficult to learn the language from books, because most of the books are full of bad advice and bad examples. There's only one book that I recommend, and that's Dave Flanagan's Definitive Guide from O'Reilly, the 5th edition. I can say without fear that it is the least bad of a very large class of very, very bad books. So yeah, it's that one, the Rhinoceros book. I recommend it as highly as I can recommend a JavaScript book. The standard which defines JavaScript was defined by ECMA, the European Computer Manufacturers Association. We'll talk about them later. Unfortunately, the standard itself is not very good. It's very difficult to read and understand, which contributed to the bad book problem, because authors could not go to the standard in order to improve their understanding of what the language does. Finally, JavaScript is a functional language in the way that Lisp and Scheme are functional languages, which puts JavaScript in a completely different class. But this is virtually unknown. So we'll be talking about this aspect of the language as we go forward. In 1992, Jim Gosling was sitting in his office at Sun Microsystems. He had been working on a language which was going to be a successor to C++. Gosling's a really smart guy, but not very good at naming things. And so his working title for the language was C++++. His friends told him, Jim, you can't call it that. You're going to have to call it something else. So he looked out of his window, saw an oak tree. And at that moment, the name of his language was changed to Oak. Gosling then got spun out into a new startup called First Person, which was going to be developing technology for interactive television applications. And Oak was used in those applications. That company failed. So in 1975, he was rolled back into Sun. After having failed in interactive media, they were sitting around trying to figure out, well, what do we do with Oak now? And in a conversation in a coffee shop, they decided that what it really needed was a new name. And so looking at the menu, Gosling decided to call it Java. At the same time, they decided that one of the first applications they would demonstrate of this new language was a web browser, because the web at that moment in time was starting to become hot. So they called the browser Hot Java. Having that browser having almost the same name as the language that it was written in caused huge confusion, which actually helped them. There was so much hype at the time about how wonderful browsers were and how wonderful Hot Java was, and that caused a huge amount of excitement about the language itself. Meanwhile, at Netscape, they had looked at Java and decided this really isn't going to work in web pages. It's way too heavy, it's way too clumsy. To do APIs in web pages and to do form validation and the sorts of applications that they anticipated, they wanted something much, much lighter. Brendan Eich was at Netscape at the time. His first idea was to do a dialect of scheme in the browser. His manager said, no, there's no way the market will accept all those parentheses. Do something that looks like Java or Visual Basic. Don't do anything weird. Just do a nice little scripting language and we'll let you do that. So he decided to base his syntax on Java and created something which became known as LiveScript. LiveScript was the first scripting language to be put into a web browser. It was also the first scripting language to be put into a web server. The LiveWire platform that Netscape was developing at that time had LiveScript in the server. The reason Netscape and Java were so exciting at the time was because it was thought that they were going to provide a way to escape from Microsoft. If the web could be established as a way of writing applications in which we're no longer dependent on operating systems, then we can get free of Microsoft and the world will be a better place. That created huge energy around both companies. They came to the conclusion that they were more likely to win against Microsoft if they joined together. If they didn't join together, then Microsoft would beat them against each other and would prevail. So they decided to create an alliance. And the stickiest part of the potential alliance was what to do with LiveScript. Sun wanted Java to be the language of the browser. It would be the way that we would add interactivity to the web. Netscape said, that's fine, except it doesn't work. So we really need to stick with LiveScript instead. There was a big battle about that. The alliance almost fell apart. Then Mark Andreessen, the founder of Netscape, had a really devious idea. He changed the name of LiveScript to JavaScript. I think he thought it was funny. I think it was a way to poke Sun in the nose. What happened instead was Sun claimed trademark ownership of JavaScript, and so they had control of the name going forward. So the next year, 1996, Microsoft looked at what was happening with JavaScript and said, okay, we need to knock that off. So they reverse engineered JavaScript, did an extremely careful job in their reverse engineering. They did not want to deal with Sun about the trademark issue, and so they called their implementation JScript. A lot of people think that JScript and JavaScript are different but similar languages. That's not the case. They are just different names for the same language, and the reason the names are different was to get around trademark issues. For the same reason, Microsoft changed the name of their implementation of Java to J++. It wasn't because J++ was intended to be a different language. It was just intended to stay away from Sun's lawyers. Netscape was alarmed at the fact that Microsoft had made a copy of their language and that Microsoft would probably go and mutate the language and they would lose control over it. So in order to prevent that from happening, they decided we need to make it a standard so that Microsoft won't be free to fiddle with it. So they took it to the European Computer Manufacturers Association, or ECMA. You might be wondering, why would a software company in California go to the European Computer Manufacturers Association, which is headquartered in Geneva? The reason was they thought they could get a rubber stamp there. But what happened was when the meeting started, Microsoft was a member, as were a number of other companies. And from the first day, Netscape lost control of the standards process. And Microsoft pretty much dictated the course of the language from that point on. In particular, mistakes that Netscape had made in the first version of JavaScript, Sun had copied in their reverse engineering of JScript and insisted that those errors remain in the standard. Because it was very important to Microsoft at that time to never do anything to cause anybody's program to break. Now, they never apologized to me when they caused my programs to break, But in the ECMA committee, that was a really important thing. And so those problems persist in the language, and we'll look at some of those today. Now, the good news about JavaScript is that it is not a web toy. It is a real language. It's a useful language. It's a powerful language. It is small but sophisticated. And it is not a subset of Java. It's a completely different language. And if you can learn to think about it in the way that it's particularly strong, it's a very effective language. Every programming language has a key set of ideas which should be distinct from any other language. Otherwise, there's no reason for it to exist. These are what I think are the key ideas in JavaScript. The first one is load and go delivery. That means that programs are delivered to the execution site as source code. In other languages, programs are delivered as executable files or as abstract class files or something like that. JavaScript gets delivered as text. The reason for that is it was originally intended to be embedded into web pages. Web pages are text, and so if you can put programs in the same medium, it's really convenient. That's no longer the preferred way of delivering programs to browsers, but that mode still exists in JavaScript. Second was loose typing. This is really controversial. A lot of the fashion right now is in strong typing, allowing compilers to check as much as possible before the program gets deployed. Loose typing, though, has overwriting benefits. There's much greater expressive power. Often programs tend to be easier to write. In this case, you don't get a choice. The language is loose typing. So if you can learn to like loose typing, you'll be more effective. It has objects as general containers. This was a brilliant idea. We'll talk a lot about this, where they have the unification of objects and hash tables. So objects are completely dynamic things in which new members and new methods can be added at any time. Another key idea is prototypal inheritance. This is really distinct from classical inheritance, which we see in most other languages. In prototypal inheritance, objects inherit directly from other objects. There are no classes. This turns out to be a really powerful idea, but it's not commonly understood very well. So you see a lot of people trying to program in classical styles in a class-free language, and that's not effective. But if you can learn to think in terms of prototypes, JavaScript can be extremely effective. The next powerful idea is Lambda. Lambda is the use of functions as first-class objects. This is something that we first saw in Lisp and Scheme. JavaScript has it. Really powerful idea. We're going to talk a lot about that. And then finally, linkage through global variables. Because of the load and go model, JavaScript doesn't have any sort of linker. So separate compilation units are all combined in a common global namespace, which turns out to have been a really, really bad idea. It has security problems, reliability problems, and other things. We'll talk about how to mitigate those. The JavaScript language has a small set of values. Those are numbers, strings, booleans, objects, and the special values null and undefined. We'll look at each of these. There's only one number type in JavaScript. There's no separate integer type. There's just number. And it's represented internally as 64-bit floating point, which is also known as IEEE 754, which is also known as double, which I think is a stupid name for a number type, but that's what it's called historically, because Fortran had something called double precision, and the name stuck. The problem with floating point is that it doesn't map well to common understanding of arithmetic. So 0.1 plus 0.2 does not equal 0.3. So you need to be really, really careful when you're dealing with things like money, because people expect it to add up right. And floating point can only give you an approximation, generally, of decimal fractions. So what you want to do, if you're dealing with cents or with dollar values, is multiply them by 100. That way you're dealing in whole cents, do the arithmetic, and then scale it back. There's a special value called nan, which stands for not a number. It is a result of undefined or erroneous operations. For example, if you divide something by 0, the result will be nan. It's toxic, so any arithmetic operation which has nan as one of its inputs will have nan as its output. So if you go through a whole series of computations, and at the end of all those equations and statements, you find a result is nan, that tells you that someplace there was a problem, but it doesn't give you a very good indication as to where that was. Nan is not equal to anything, including nan. So nan equals nan is false. Also, nan is not less than nan, and nan is not greater than nan. Nan is a really perplexing value. Also, in JavaScript, even though nan stands for not a number, it is a number. If you ask the type of a value that is nan, the result is number. There's a number function which can convert a value such as a string into a number. That's handy if you have something that you take out of a form field. Generally, a text field will be text. You need to turn it into a number before you can do arithmetic on it. The number function will return nan if the string cannot be converted into a valid number. JavaScript also has a plus prefix operator which does the same thing, and we'll see that later. There's a parse int function which is specialized for just parsing integers. And generally, you should always include the radix argument, which tells it what base to calculate in. The reason for that is it stops at the first non-digit character that it sees. And if the first digit is 0, it is allowed to interpret it as an octal constant. And so a leading 0 could cause it to think it's octal, and then the next digit is not an octal digit, and so you get a result of 0 rather than a result of 8. So for that reason, I recommend when you're using parseInt, always use a radix. One mistake that JavaScript copied from Java was having a separate math object. Java did that so it could easily jettison math for applications in which you didn't want to pay for having a math library. But it turns out that's just not useful, and JavaScript repeats the same mistake. So there are a number of useful mathematical functions available. These are some of them. Probably the most useful of them is going to be the floor method. Math.floor is the thing you use to take the integer part of a number. JavaScript has strings, where a string is a sequence of 0 or more 16-bit characters. The encoding is, in Unicode speak, UCS2, not UTF-16. That's because JavaScript was created before Unicode got to that level of maturity. The difference between those two is that UCS2 is not aware of surrogate pairs for the extended character range. Now, it turns out the extra million characters are very rarely used, so it's generally not a problem, but it's something to be aware of. There's no separate character type in JavaScript, so if you want to talk about just one character, it's just a string of one character. It's just a short string. It's not a separate type. Strings are immutable, which means that once a string is made, it cannot be modified. So you can't go into the middle of an existing string and manipulate the characters. You have to make a new string, which you can easily do by concatenating together pieces of old strings. Similar strings are equal with the double equal operator, which is good. Java got that wrong. And you can write string literals in either single quotes or double quotes. Both work the same way. There are no magic quotes or semiquotes or anything like that in this language. All strings have a length member, which you can use to determine the number of 16-bit characters in it. This is not necessarily the same as the number of Unicode characters in it, again, because it doesn't know about UTF-16. There's a string function, which can be used to turn a number into a string, and there are also number methods, which can do it maybe a little bit more gracefully. Strings also have methods. Strings are objects in this language. So there are lots of useful methods that you can perform on strings to get characters from them or extract substrings or search on them or perform other sorts of surgery on them. You'll be glad to know there are exactly 2 Boolean values in JavaScript and that they are true and false. A lot of languages can't make that claim. There's a Boolean function which will take a value, and if the value is truthy, it returns true, and if the value is falsy, it returns false. We'll talk in a minute what truthy and falsy mean. Then there's null, which is the value which isn't anything. That's sometimes a useful thing to have. And then there's undefined, which is the value which isn't even that. Undefined is the default value for variables. So if you define a variable and don't initialize it, it gets initialized for you with the value undefined. This can be really confusing because a variable can be both defined and have the value undefined at the same time. I think maybe they could have picked a better name for this because it's trying to describe two states at once. Undefined is also the value that you get when you extract a member from an object that doesn't have that member. So it's the missing value, undefined. So I talked about truthy values and falsy values. These are the falsy values: false, null, undefined, the empty string, the number 0, and nan. All other values, including all objects and everything else that we're going to see in the language, are truthy. The ones to watch out for are the string 0. It's not the same as the number 0, so it is truthy. Also, the string false is truthy, even though it looks like it's false, because all non-empty strings are truthy. Yes? That's a good question. Case sensitivity. All the keywords that we're going to see in the language are lowercase. There are some methods we'll see which are camel case, but generally it's all lowercase, and it is case sensitive. So those are the simple values. Everything else in the language is objects. So you may have heard that JavaScript is not an object-oriented language. I'm going to try to convince you that it is, because it's all about objects for the rest of the day. So in particular, the style of object which is implemented in JavaScript is the dynamic object, the unification of objects and hash tables. The new object constructor produces an empty container of name-value pairs, where a name can be any string and a value can be any value except undefined. So once we create an empty object, we can augment it by adding new members to it. Members can be accessed with dot notation or with subscript notation. Objects provide both syntaxes, which is a little different from most other object-oriented languages. Now, even though these things behave like hash tables, there's no hash nature visible. By that I mean there's no hash codes or rehash methods or anything like that. And in fact, in the JavaScript implementation in IE, they didn't even bother to implement hash tables. They've got linked lists for these things. So for some object operations, it runs noticeably slower on JavaScript than in other implementations. JavaScript is a loosely typed language, which means that any variable is capable of receiving any kind of value. And any parameter to a function can receive any kind of value, and any kind of value can be returned from a function. The language is not untyped. The language actually has a pretty robust sense of what types are, but it's very loose in that it allows any type to be used anywhere. JavaScript is syntactically a member of the C family. It's got all the curly braces and everything. It differs from C mainly in its type system, which allows functions to be values. That's one of the big ideas in JavaScript and what distinguishes its syntax. Its identifiers follow the same rules as most of the C languages. An identifier starts with a letter or with an underbar or with a $, and is followed by 0 or more letters, digits, underbars, or $, and the name will be case sensitive. By convention, all variables, parameters, methods, and function names start with a lowercase letter, except for constructors, which start with an uppercase letter. And we'll talk about constructors later. Initial underbar is reserved for implementations. They seem to be really popular in a lot of people's programs. I don't know why. Doesn't seem to be any reason for them. Generally, it's better not to use them just to make sure you don't have a conflict with some internal variable. $sign was added to the ECMA specification specifically for machines, meaning macro processors and program generators, things like that. So it's recommended you not use $signs in your own programs. However, some of the Ajax community has fallen in love with $signs, and they're using $signs all over the place. So if you want to ignore the standard, you can go ahead and do that. JavaScript has a bizarre reserved word policy. All of these words are reserved. But only the ones in boldface are actually used in the language. They got really heavy-handed in what they chose to reserve. Also, they apply this list in places where they shouldn't have. When you retrieve certain things using the dot notation, or member names cannot be reserved words. This was just an error in the language which has not been corrected yet. There are two styles of comments in the language. You can do / as a prefix, or you can do / as a bracketed comment. It has the same set of operators that you would expect to see in any C language. Most of them work the same way as they would in any other C language, but there are some differences, and we'll go over those. The plus sign is used for both addition and concatenation. The rule is if both operands are numbers, it adds them, and otherwise it turns them both into strings and concatenates them. This was a mistake. In a language which is loosely typed, having this kind of operator overloading was just dangerous. And we see a lot of mistakes made from this. For example, you see that expression where you're trying to concatenate a $sign to an addition, but you end up concatenating it all together. So you need to be careful that when you intend to add, that the operands are numbers. Plus can also be used as a prefix operator, which will convert an operand into a number. So plus the string 42 yields the number 42. We can add strings together by using the plus operator. The reason I put this one in parens was this one could be confused with ++, which means something completely different, and we don't want that confusion. So it's best to avoid that construction. Division of two integers can produce a non-integer result, so you need to watch out for that. So 10 divided by 3 isn't 3, and it isn't exactly 3 1/3 either. It has equal and not equal operators. Unfortunately, these operators can do type coercion, which can interfere with producing the correct result of the comparison. There's also a triple equal and a bang double equal operator, which do exact equality of both value and type. And I recommend you use those instead. Netscape at some point recognized that they had made a mistake. And so the way they wanted to correct it was to fix double equal to be exact and added triple equal to the language to be coercive. But Microsoft said, no, we don't want to do that, so they reversed it. So the language now requires triple equal when you want exact equality. It's a little harder to type because you have to go bang, bang, bang instead of bang, bang. But the programs will run a tiny bit faster and will probably be a little bit more reliable. JavaScript has a logical AND operator, which is also known as the guard operator. It works a little differently than it does in some of the other C languages. If the first operand is truthy, it returns the second operand. Otherwise, it returns the first operand. It doesn't necessarily return true or false. It can be used to avoid null references. So I've got an if here. If A is truthy, then I'll return a.member. Otherwise, I'll just return A. I could write this here just as return A guarding a.member. Does the same thing. It's a lot smaller, a lot faster. Similarly, there's a logical OR operator, which is also called the default operator. And it works the opposite as the other one. So if the first operand is truthy, the result is the first operand. Otherwise, the result is the second operand. We can use this to fill in default values. So here we've got an input that we may have pulled out of a form element. And we want to assign a value to last. If input has a value, that's what we'll put in there. But if input is falsy, we'll put that in there instead. So we could write that as an if statement. This is much more compact. And if you get used to thinking of this as default, then it's a really expressive way of writing these sorts of expressions. It has bang, the logical not operator. If the first operand is truthy, the result is false. Otherwise, the result is true. If you say bang, bang, that'll produce a Boolean, because when you do that and do it again, you'll get either true or false. It has bitwise operators, and you might wonder, what sense does a bitwise operator make in a language that doesn't have integers? So the way they work is they take the floating point number, convert it into a 32-bit integer, do the logical operation on it, then convert it back into floating point. So some people, when they use these operators, they think that it's going to go faster. You know, if I'm going to do a shift instead of multiplying by 2, that's going to be a big win. In this language, don't do that. If you don't intend for a bitwise operation, don't use these operators because it's going to be slower.